I am busy working from the Gauteng June exam from 2024 for mathematical literacy. I am continuing with question 3 from that paper. This was recorded right after the World Cup. So they speak about, with its 4th Rugby World Cup victory, South Africa stands at the top of the ranking list. Commitment to the cause, confidence to do a job, belief in the system. This is the South African way. It has won South Africa the 2023 Men's Rugby World Cup. They say Annexure C shows the heights of an average South African man and the rugby players with their positions in the team as well as their respective heights. And we must use Annexure C to answer these questions. 3.1.1 asks, determine the range with regard to the rugby players used in this set of data. A reminder that range refers to the largest data value or the highest data value minus the lowest data value. It gives us an indication of how far the data is spread. We have 8 players' heights listed here, as well as the average South African man. Argees Snyman was the tallest at 2.06 meters, and then Cheslin Colby was the shortest. This is obviously a mistake. It's either supposed to be meters or 170 centimeters. In a paper like that, it will be corrected beforehand if pointed out in time. If it is not pointed out in time, you work with the information as written. So the range in this case is 2.06 meters minus 1.7 meters. That gives us 0.36 meters. If you converted them to centimeters, it would have been 206 centimeters minus 170 centimeters, which is 36 centimeters. They do not tell you which unit of measurement to give your answer in, therefore it can be either or. Right, 3.1.2 says the average height of a South African rugby player is 1.86 meters. Use the following formula and determine the total height in meters of the 15 rugby players in the Springbok squad. So we can't go and actually calculate the combined height of all of them because we only have the height of 8 members. That's why they give you the average. I'm going to be using this. Remember, mean and average are the same thing. They're the same, they're different words for the same thing. In this case, they told you what the average height is, but, what the formula for average or mean is, but you must also know it. Right, so they tell us that the average is 1.86 meters. And then it would be the sum or total height as they describe it in the formula over 15, because there were 15 different heights that were added together. If you are very unfamiliar with algebra, even grade 8 algebra, you might be unsure, but we need to multiply with 15 on both sides to get the total height alone. And this is 1.86 meters, and they're asking us to answer in meters, so we're not going to convert it to anything. So the total height was 1,86 meters multiplied by 15, which is 27,9 meters put together. If you're unsure why we're doing this, we have an answer on this side equal to what we're looking for divided by 15. So to reverse the operation to get the missing value alone, we need to do the inverse operation, which is multiply by 15. The next question, they say, rugby is arguably one of the most body type inclusive sports. Unlike long distance running or bodybuilding, whatever shape you are, there is a place for you on the rugby field. Annexure D shows two box and whisker diagrams comparing the weight of the New Zealand and South African rugby teams. So they are referring to these box and whisker graphs. We can see that the minimum for both teams is 70 kilograms. And then the maximum here is like roughly 119, 118, where the upper quartile here would be roughly 112, 113. Their maximum looks like 140 over here. They are asking us to work with this. This is the 5-point summary for New Zealand. They give us quartile 3 maximum, quartile 1 minimum, and quartile 2. Just a reminder that our 5-point summary is usually minimum, quartile 1, quartile 2, quartile 3, and then maximum. It doesn't matter in which order you do it as long as you have all 5 those values. A general reminder that these quartiles divide your data into 4 equal parts, so into quarters. So this is obviously the minimum value and the maximum value. Quartile 2 is your actual median. In other words, the middle value, the middle data value, once your data has been arranged in ascending or descending order. I always think of the word medium. When I hear median, it is the middlemost value. Then quartile 1 is the median of the lower half of your data. And quartile 3 is the median of the upper half of your data. These are also called the lower quartile and the upper quartile. Alright, so what does that look like represented graphically on a box and whisker? So we have our minimum, then it would be quartile 1, quartile 2, and quartile 3, and our maximum. Alright, for our purposes, you need to understand that 25% of your data lies here. Another 25% of your data lies there. Another 25% of your data lies there. And the last 25% of your data lies here. If this is minimum, quartile 1, quartile 2, quartile 3, and maximum. Then we have something that is called the interquartile range, which is the upper quartile minus the lower quartile. The largest quartile or the highest quartile minus the lowest quartile, as range is highest value minus lowest value. If you're unsure about how to find these data values, how to find your quartiles, there is a video that I did on it earlier on in this year. Right, so we have been provided the 5-point summary or the 5-number summary, and A, quartile 1, is missing. If the interquartile range is equal to 25, determine the value of quartile 1. So, for 3.2.1, we know that interquartile range is quartile 3 minus quartile 1. They told us the interquartile range is 25. Quartile 3 is given as 113. And we're looking for A. So the difference between 113 and 25 should give us our A value. So 113 minus 25 gives us 88 kilograms. Again, if you're unsure why we did this the way that we did it, think of it in this way. This would mean that the box is the difference between 113 minus 25. I can now actually go fill in these values on the actual box and whisker graph. That was the minimum. The maximum was 140. The quartile 1 was 88. We just worked that out. Quartile 2 was 100. And this was 113. Now, for example, if I ask you what percentage of the players are or weigh less than 113 kilograms, it would be this 75% here, because that's 25, 25, and 25. If I ask you what number of players are less than 113 kilograms, you would say 75% of 15 players. Right. The next question says, which one of the following terms best describes the data displayed in the box and whisker diagram? Discrete or continuous, and give a reason for your answer. Now remember that the difference between discrete and continuous data is as follows. Discrete data can be counted. It would be the number of people in a room, the number of people who play a particular sport, the number of people with tickets to a concert, things like that. Whereas continuous data is measured. This is a more abstract type of data: weight, height, distance, length, time, temperature, anything that can be measured. You can also say that this can be like fractions and decimal points, where this has to be whole numbers. So discrete data can be represented using pie charts and bar graphs. Continuous data is represented using histograms and broken line graphs. So again, we're looking at the weight of the two teams, which means that we are working with continuous data. The reason is that weight is measured rather than counted. Now there is a reasoning behind it. Continuous data changes over time. You don't just jump from 13 centimeters to 14 centimeters. You have the millimeters and the increments in between. So it continues to grow over time, as opposed to the number of something, which cannot be like, we can't have 1 1/4 people unless we're serial killers. Alright, the box and whisker diagrams compare the weight between the New Zealand and South African rugby players. What term is used to define a value that is very far apart from other values in the data set? That would be an extreme or an outlier. It is a term that you need to know. It is a term that is used within data handling. So we need to know what minimum, maximum are, obviously, mean, median, and mode, range, and extremes and outliers. Then we need to know what quartiles are, how to find them, and how to work out the interquartile range. a common example of an extreme would be if the majority of the class get between 60 and 70% for a test, and one person gets 35%, or one person gets 98%. Those are both extremes. They're very far apart from the rest of the data values. In our given context, say that the majority of the team for New Zealand lies between 70 and 113 kilograms. And then we have a player who's 114 and a player who's 115. And then suddenly the next heaviest person is 140. That would be an extreme. All right. According to international statistics, there is a great difference between salaries paid to soccer players and salaries paid to rugby players. Annexure E shows information on the salaries paid to famous rugby players and soccer players in different currencies. Use the information in Annexure A to answer the following questions. We are given this particular one. These two are soccer players. They're paid in euros. And then these are rugby players who are paid this amount million per annum. They give us the exchange rate for euro and South African rand, as well as dollars to South African rand. So the first question says, Neymar Jr. and Cristiano Ronaldo are two of the most famous players in the world of football or soccer. Convert Cristiano Ronaldo's yearly salary to rand. This is quite easy. We're going to be taking Cristiano Ronaldo's annual salary and converting it to rand using this formula here. I always say that if you're going in the direction of the conversion, you multiply. So if we're going from euro to rand, we're going to multiply. And if we're going from rand to euro, we're going to divide. We are, in this case, going from euro to rand, so we're going to multiply. So this would be 3.1, which is 35 million euro. And we're going to multiply that with 20,05. Or it doesn't even need to have the rand symbol. In fact, I think it's actually better to leave the rand symbol out and only answer in rand at the end. 20.05. Oof. Okay, 1, 2, 3. 1, 2, 3. Okay. 750. 1, 2, 3. There we go.